All right, so what we're going to do now is we're going to look at how we can solve equations with fractions. And most of the ways we do this is we focus on the denominators. And the least common denominator will sometimes come in use. But I want to show you kind of the brute force method first. So what I'm going to do is I'm going to treat it like Shrek. I'm going to treat it like onions, and I'm going to peel back layers. Now notice the fraction 5/12, I think I'll look at, would be great if I could multiply it by 12, because the 12 would cancel out and I'd just be left 5. So I'm going to do that. I'm going to multiply it by 12. That'll clear the fraction. But whatever you do to one side, you have to do to the other. So I'm going to multiply the other side by 12. So I'll start with my left-hand side. I'll distribute. And so 12 times y is 12y. Then I'm going to have 12 times 2/3. And then coming over here, these cancel, and I have 5. Now if I look at this, 3 goes into 12 4 times. And I get 4 times 2 up here. So I can rewrite this as 12y minus 8 equals 5. And now I have that nice linear equation I had before. So I can add 8 to both sides, because that'll make this go away, and I get 12y equals 13. Then I want to divide by 12, but whatever I do to one side, I do to the other, and that gives me y equals 13/12. So that is one way to work on fractions. Let's look at some different variations of how fractions come up into equations, and we'll develop some different techniques. So let's say we have 1/5 of y equals 2. Well, we can think of this as multiplying by 1/5, so I want to undo that. And so the best way to undo that is to multiply by the reciprocal. But whatever I do to one side, I do to the other. And so 1/5 times 5 will leave me with a solitary y, and 2 times 5 leaves me with 10. All right, let's look at a slightly more complicated example. Let me change colors here. I like changing colors as I change problems. So we're going to have y upstairs in a fraction. We're going to add another fraction to it, and we get a whole number. Again, it would be great if I could get rid of this 8. So I want to multiply this by 8. But I have to, that's going to change the value of this. So the best way to do that is to multiply the whole side by 8. That way everything scales the same. And whatever I do to one side, I do to the other. So I'll distribute this. 8 times y over 8 is y. 8 times 3/4, well, the 8 and the 4 are going to cancel, leaving me a 2. So that's going to be 6. And 2 times 8 is 16. Subtract 6 from both sides. And so you get y equals 10. Sometimes I have fractions everywhere, and I don't have a nice clearing term. And so if I have y divided by 2 equals y divided by 5 plus 3/2, well, I can find the LCD. So if I look at all these fractions, 2 is prime and 5 is prime, and so the LCD is 10. So I can multiply the whole equation by 10. And what that means is I'm multiplying both sides by 10. And so 10 and 2 cancel, giving me 5y. I'll distribute this 10 to both parts. So 10 divided by 5, that gives me 2y. And then in the 10 and the 2 gives me a 5, and 5 times 3 is 15. Now I'm going to bring all my y's to one side, so I'm going to subtract y from this side. But whatever I do from one side, I do to the other. And so 3y equals 15. And now I'm going to divide both sides by 3, and y is equal to 5. There is another way to do this particular problem. If you don't see the LCD, you can clear the fraction. So let me look at the problem again. You can clear the fractions one by one. So if for some reason these denominators are complicated and you can't find the LCD, you go, you know what? I want to get rid of that too. So I'm going to multiply this side by 2, and I'm going to multiply this side by 2. These two cancel, leaving me with y. And this 2 is going to distribute to both of these terms. So when it comes to this term, I'm going to get 2y over 5 plus 2 times 3 is 6. I guess they'll cancel, and I'll get a 3. But I still have a fraction. So now I'm going to get rid of the 5 by multiplying both sides of the equation by 5. So instead of finding the LCD, I can just attack each fraction as I see it. So on this side, I get 5y. Oops, multiply by 5. Whatever you do to one side, do to the other. And I'm going to distribute that to both terms. Well, here the 5's cancel, and so I get 2y, and 5 times 3 is 15. And you'll see that's the same thing I got here. So if you can't find the LCD readily, or there's variables or things in there that are kind of making it hard for you to see the LCD, just focus on one fraction at a time and multiply the denominator across the whole equation. Each term is going to get multiplied by it. If you still have a fraction left over, repeat. And eventually you'll clear all the fractions, and you'll be able to solve these equations with fractions in them. All right, have fun with Chapter 4. If you need anything, email me.